Hello, and welcome to the lesson on solving inequalities. The three things that we are going to learn in this lesson are: first, we'll understand what are inequalities and how are they different from equations. Then we'll understand some properties of linear inequalities. And finally, before we end the lesson, we'll also understand the properties of quadratic inequalities. So let's begin then. Let's say there are three witnesses who are testifying in a court of law. The first witness says there were 7 people at the scene of crime. The second one says there were not more than 10 people at the scene of crime. Whereas the third witness says there were at least 4 people at the scene of crime. Now, my question to you is, which of these three witnesses could be telling the truth? Now, the interesting thing is the manner in which they have made the three statements. For all you know, all three of them could be speaking the truth. In the first case, the first witness was definitely sure about the number of people she saw at the scene of crime, which is 7. So that is equivalent of a definite value and hence equations. Remember, when we solve equations, we end up getting definite values. The other two were not sure about the number of people they saw at the scene of crime, but the numbers that they suggested, okay, definitely signifies that it's a representation of an inequality. So what is an inequality and how is it different than an equation? Well, in case of an equation, the answer is a definite value, in this case 7. Whereas in case of an inequality, okay, it's a range of values. For example, the second witness says there were not more than 10 people at the scene of crime. So he was sure that there were definitely not more than 10. But the number that he suggested, okay, can mean that there could be anything less than or equal to 10 people, correct? Anywhere. For all you know, it could be 7 people, which is the same as what the first witness has said, correct? The third witness, on the other hand, says there were at least 4 people. What does at least 4 people mean? That minimum there were 4 people. He's sure about having seen 4 people, but he's not sure the upper number, okay, which means he's not sure exact number, but he says, yeah, I saw minimum 4 people. It could be any number above that. For all you know, it could be 7 people, which is what the first witness has suggested, right? In other words, in their own ways, all three of them could be speaking the truth, correct? So in case of a equation, you end up getting definite values. In case of inequalities, you get range of values, right? Less than or equal to 10 would mean 10, 9, 8, 7, 6. It could be any of those values. Likewise, greater than or equal to 4 would mean it could be 4, 5, 6, any value greater than or equal to 4, correct? So it's a range of values that you end up getting in case of inequalities. Let us first understand the notations that we use in case of equations and inequalities. Okay, so you are all aware about the two horizontal lines, which means equal to. Two wiggly lines indicate that it is approximately equal to, okay, which means it's not an exact answer, but it is close to the correct answer. Two lines with a crossed line indicate that their values are not equal to. Then you are aware about the less than and greater than some symbols, right? The less than symbol with a dash and the greater than symbol with a dash indicates respectively, okay, less than or equal to and greater than or equal to, right? So how would we say each of these? The first one, the first row is x greater than 9. The second one is x less than -2. We are aware of that, right? The third row suggests x is greater than or equal to 6 because of that little line below that greater than symbol. It is greater than or equal to 6. In the next case, it will be x is less than or equal to -7. Once again, that little line below less than symbol, less than or equal to -7. The next one, okay, that's interesting. -2 less than x less than 3. So there are two ways of putting it. One way of saying it is x is greater than -2 and less than -3. Or if you want to say it in a slightly better form, it simply means x lies between -2 and 3, but neither of them is inclusive in the range, which means because the little lines are not there, which means neither -2 nor +3 is inclusive in that range. It strictly lies between -2 and 3. The next one, as you can see, okay, x lies between -4 and 7. However, because of the little lines below each of those symbols, it means both of these values are inclusive. So -4 and 7 are both inclusive in the given range. And finally, if you look at that, there's a little line below the symbol corresponding to -1, but there's no line in the symbol corresponding to 5, correct? How do we say that now? X lies between -1 and 5, and -1 is inclusive, but 5 is not, correct? Because the little line -y is a part of the range, but 5 is not a part of the range. Let us now look at some of the properties of linear inequalities. So let's say x equals to $3 and y equals to $5. Okay, so assuming that each of these coins has the same weight, so clearly if I put them in a balancing pan, the moment I put x on one side, let's say left side, and y on the right side, which one's going to end up being heavier side? Clearly, y is 5 coins of the same kind, x is 3 coins of the same kind, so y will be heavier. So the balance will tilt, okay, towards y, something like this, correct? Now let's understand some simple properties. What if I were to add 1 coin on each side? So currently, y is greater than x, right? That's why the scale is tilted in favor of y, right? And y is 5 coins, x is 3 coins. So clearly, y is greater than x. What if I were to add 1 coin on each side of the pan, right? Now you would realize that the tilt will not change. It will definitely not change the other way, right? Will it tilt in favor of x? No. Which means even after adding a coin, the inequality between x and y would still remain, right? X plus that coin will still be lesser or smaller than y plus that coin, right? So rule number one, if x is less than y, then x plus a will also be less than y plus a. Right. Now, what if I were to remove 1 coin from each side of the pan? Will the scale tilt in favor of x? No, still not, right? So even after I removing 1 coin, because I have removed the same number of coin from either side, okay, the inequality between them will be maintained, right? So if x is less than y, then x minus a will still be less than y minus a, correct? So to generalize these two rules that we have learned, it simply means adding the same quantity or subtracting the same quantity from both sides of inequality does not change the inequality. So whatever you add or subtract, as long as you're adding the same thing on both sides or subtracting the same thing from both sides, the inequality between the two quantities doesn't change. Right. Let's look at the next property now. Okay. Oh, let's look at the same property once again from a different point of view. So we know that -6 is smaller than 4. Now, if I were to add a 3 on both sides, clearly each of these points will move 3 units to the right. Okay, so -6 will move to -3 and 4 will move to 7. Still, you would realize that -3 would be smaller than 7, which means the inequality between these 2 points would still maintain because both of them have moved the same units to the right. The same is if I subtract. Okay, -6 is clearly less than 4. If I were to subtract 3 from both sides, both these points will now move left by the same number of units, which is 3. So -6 will move to -9 and 4 will move to 1. And as you can see, -9 is still less than 1. So both of these points are moving the same units to the right or left, and hence the inequality between them will not change. Right, okay. Now let's look at a grasshopper. Let's say one jump of a grasshopper is equivalent to 2 units, whereas one jump of a frog is equivalent to 5 units. So clearly one jump of a frog is bigger than that of a grasshopper, right? 2 is smaller than 5 or 5 is greater than 2, whichever ways you look at it. Now, what if I compare two jumps of either of them? So two jumps means two times as many, right? So in case of grasshopper, it will reach 4 units, whereas in case of frog, it would have reached 10 units. Clearly, okay, the frog is still further away than the grasshopper on the positive side. So 10 is clearly greater than 4, right? What if I were to multiply by a negative value, which means they are now moving on the negative scale? So let's say I multiply both of them by -2, which means grasshopper is now taking two jumps on the left. So where will it reach? It will reach -4, right? Each jump is 2 units, but on the left, if it goes, it will reach -4. On the other hand, the frog, because each jump is 5 units, it will, in two jumps, it will reach -10, as you can see, correct? In two jumps, which means the frog has reached a smaller value. Okay, it has reached a further negative compared to the grasshopper. The grasshopper is on a bigger value, -4, whereas the frog has reached -10. So in fact, the inequality between them has reversed, as you can see, because the grasshopper is -4, the frog has reached -10, and -4 is a bigger value than -10, right? If you remember, on the number line, every value on the right will be bigger than the values on the left, correct? So -4 is greater than -10. So how do we define this rule then? Okay, so if x is smaller than y, then ax will be smaller than ay provided a is positive, which means multiplying by a positive number doesn't change the inequality, whereas ax will be greater than ay if a is negative. If I multiply both sides by a negative number, then the inequality between them will reverse. So multiplying and dividing both sides by the same positive quantity does not change the inequality. However, multiplying and dividing both sides by the same negative quantity reverses the inequality. Make a note of that. If I multiply or divide by negative quantity, the inequality reverses. Let's look at that with a different example. So we know that 100 is greater than 50. If I multiply both sides by 5, I will get 500, which is still greater than 250, right? Or even if I divide by 5, I'll get 20, right, which is greater than 10. So the inequality would remain between them. So if x is greater than y, then multiplying by a positive quantity does not change the inequality. What if I were to multiply both sides by -5, correct? So in the first case, I will have -500 and -250. So -500 is clearly less than -250. In the second case, if I'm dividing by -5, I'll get -20 versus -10, and -20 is smaller than -10. And hence, if I multiply or divide by a negative quantity, then the inequality would change. Okay, they were greater, 100 was greater than 50 earlier, but after multiplying by a negative quantity, okay, the left hand side has become smaller than the right hand side, as you can see. Well, if x is greater than y, what can you say about 1 over x and 1 over y, which means what happens if I take the reciprocal? Now let's take three different cases here. Both numbers are positive, both are negative, and one of them is positive, the other is negative. So 5 is greater than 2, we know that. If I take the reciprocal, 1 by 5 will end up being a smaller quantity than 1 by 2 because the denominator of 1 by 5 is bigger, the fraction will be smaller, correct? So the inequality has changed. What if in the second case, -5 is smaller than -2. However, the minute I take the reciprocal, I'll get -1 over 5, which ends up being a greater quantity than -half, right? Which means once again the inequality has reversed. What about positive and negative? One quantity is positive, the other is negative. 5 is greater than -2. If I take the reciprocal, the positive quantity would still remain positive and the negative quantity would still remain negative, which means the inequality will be retained, right? 1 over 5 will still be greater than -half. So what's the rule? Taking the reciprocal changes the inequality only if both the numbers have the same sign. Either both are positive or both are negative, then taking reciprocal will definitely change the inequality. If one of them is positive and the other one is negative, then even after taking the reciprocal, the positive quantity would still remain bigger than the negative quantity. Right. What if x over y is greater than 0 and x over y is less than 0? So to understand this, let's understand what is greater than 0 and less than 0. Greater than 0 means it's a positive quantity. So when would a fraction be positive? Okay, imagine a fraction. When will that be positive? It will be positive if both numerator and denominator are positive, that is x and y are both greater than 0, or it will be negative, it will be positive, or if both numerator and denominator are negative, right? So imagine numerator and denominator both are negative. If I put it in the fraction, the negatives cancel out and I'll end up getting a positive quantity, right? So the fraction will be positive or greater than 0 if both x and y are positive, which is greater than 0, or both x and y are negative, which is less than 0. Likewise, okay, if x over y is less than 0, which means it's a negative quantity, that specifies or signifies that one of them has to be negative, which means either x is positive, y is negative, or it could be x is negative, y is positive. Correct? Because a fraction will be negative only if one of them is negative, numerator or denominator. Let's take example. Okay, 2 over 3, both are positive. That's a positive value, right? Greater than 0. Minus 2 over minus 3, that's again a positive quantity because minus and minus cancel out, so you get a positive quantity. So if both are positive, both are negative, x and y, you will get a fraction which is greater than 0. Okay, minus 2 over 3, that's a negative fraction, and 2 over minus 3, that's again a negative fraction. So if one of them is negative, then the fraction would be negative. Right. What if x over y is greater than 1 versus x over y is less than 1? Okay. What do you mean by greater than 1? Okay. Now, in case of positive quantity, when will a fraction be more than 1? When it's an improper fraction, right? Improper fraction means the numerator has to be bigger than the denominator. Okay, so if both x and y are positive, then clearly x has to be bigger than y, greater than y, correct? However, if x over y is negative, right, x and y are both negative, then the magnitude of the numerator has to be bigger than the magnitude of the denominator. Okay, because minus and minus will cancel out, only the magnitude will remain. So in case of negative numbers, if the magnitude is bigger, the number is actually smaller, right? So if you look at it, if x and y are both positive, then x has to be greater than y. Whereas if x and y are both negative, then x has to be smaller than y. Okay. In case of x over y being less than 1, okay, it's just the reverse. So in case of positive numbers, x and y, x has to be smaller than y because in this case, it will be an improper fraction, right? Improper fraction, the values are less than 1. Okay, improper fractions are fractions, but the denominator is bigger than the numerator. So y is greater than x, correct? However, if both x and y are negative, then the negatives would cancel out. You're only left with magnitude, right? So a negative number with a bigger magnitude will actually end up being a smaller number, right? That's why x is greater than y. Now, obviously, explaining in terms of variables is a little confusing. Let's have a look at the numbers. You'll understand it. 5 over 2 is greater than 1. It's 2.5, correct? Because both of them are positive. Okay, the fraction will be greater than 1. Minus 5 over minus 2. Okay, now if you look at it, x is minus 5, y is minus 2. So x is smaller than y. But because both x and y are negative, the fraction would still be greater than 1 because negatives cancel out. Likewise, okay, if you look at it, x is 2, y is 5. So x is smaller than y. That's why the fraction was less than 1. But if both of them end up being negative, then for the fraction to be less than 1, x has to be minus 2 and y has to be minus 5. And as you can see, x is greater than y. Minus 2 is a bigger value than minus 5. Okay, 1 over x is greater than 0. 1 over x is less than 0. That's easy, right? A reciprocal of a number will be positive if the number is positive, right? So if x is greater than 0, the reciprocal will be greater than 0. If x is negative, then the reciprocal will also be negative, right? That's what it means. As you can see, if half is greater than 0, then the reciprocal of half, which is 2, will also be greater than 0. And minus half is less than 0. So reciprocal of minus half is minus 2, will also be less than 0. Finally, when will 1 over x be greater than 0 and 1 over x be less than greater than 1 and 1 over x be less than 1? Now, 1 over x, for 1 over x to be greater than 1, x should lie between 0 and 1. Make a note of that. Whereas for 1 over x to be less than 1, x should either be greater than 1 or it should be less than 0. Let's understand this using examples, okay? So let's say x lies between 0 and 1. Okay, let's say x is a half. Then the reciprocal of half is 2. So 1 over x actually ends up being greater than 1. On the other side, if x is a value which is greater than 1, let's say 2, x is 2, then the reciprocal of 2 is half, will be less than 1, right? Also, if x is negative, which is x is less than 0, x is negative, let's say x is minus 2, then the reciprocal of minus 2 will be minus half, which is again a quantity which is less than 1. Okay, so how do you think we can solve this inequality? X over y is greater than 4. What can you say the relation between x and 4y is? Right? So first of all, let's deduce some relationship from this. If x over y is greater than 4, it means that fraction x over y is positive, which means both x and y are greater than 0 or both x and y are less than 0, right? What is the operation which will take y to the right hand side, which means from the denominator on the left, it will go on to multiply with 4 on the right hand side. What operation will take it there? We are multiplying both sides of the equation by y, right? That's how on the left, the y cancels out, and on the right, we'll be left with 4y. Now remember, while multiplying the inequality, we need to be careful. If I multiply by a positive quantity, the inequality is retained. If I multiply by a negative quantity, the inequality is reversed. Correct? By the same logic, if y is positive, which is greater than 0, then x over y will be greater than 4. The inequality is maintained. However, if y is less than 0, which is y is negative, then multiplying by y on both sides has to reverse the inequality. So x over y will be less than 4. Now, how will an additional information x plus y equals to 7 to the same equation or same inequality change the entire game? Now, from the first inequality, x over y is greater than 4, we can deduce that the fraction x over y is positive, which means both x and y can be positive or both x and y can be negative. However, if you look at this equation, x plus y equals to 7, which is an additional information given to us, we have two numbers which add to a positive quantity 7. If both are negative, x and y, can their sum be positive? If both x and y are negative, their sum cannot be positive, which means x, y less than 0 is ruled out. Correct? So the only possibility remains is x and y both are positive. So if y is positive, multiplying both sides by y should not change the inequality, and hence it is always greater. X will be always greater than 4y, as you can see. Finally, let's have a look at quadratic inequality. X squared is greater than 36. When is that going to happen? Now, simple values that I can think of is when x is any value greater than 6, right? 6.4 squared, 7 squared, 9 squared, 11 squared. All of these are greater than 36. So x should be greater than 6. But then there are some negative values which when squared gives you a value greater than 36. We should not ignore them. For example, minus 6.4 squared, minus 7 squared, minus 9 squared, and minus 11 squared will always give the value which is greater than 36, right? And hence, on one side, x could be greater than 6. On the other side, we can also have x can be less than minus 6. So the solution for this is x could be greater than 6 or x could be less than minus 6. What if x squared was less than 36? Well, we can easily think of positive values. If x squared is less than 36, then x can be any value less than 5, right? Less than 6, sorry. 5.4 squared, 5 squared, 3 squared, 1 squared are all less than 36. So x is less than 6 for sure. But then there are some values which we are ignoring, particularly the negative values, which are these set of values, right? Minus 5.4, minus 5 squared, minus 3 squared, minus 1 squared. They will always give you an answer which is less than 36, which means on one hand, x is less than 6. On the other hand, x could also be greater than minus 6. Any value which is greater than minus 6, minus 5, minus 3, minus 1, all are greater than minus 6 can also satisfy, right? Now, the second case, which is x is less than 6, x is greater than minus 6, can be written in a combined form like this. X lies between minus 6 and 6. Look, x is greater than minus 6, x is less than 6. And finally, what happens if we have quadratic inequality in this format? X minus 3 times x minus 8 is greater than 0. So we have two numbers which when multiplied gives you a positive quantity. When will two numbers multiplied give you a positive quantity? One, when both are positive, which means x minus 3 is positive and x minus 8 is positive, which means both are greater than 0. When will that happen? When x is greater than 3 and x is greater than 8. Now, if x is greater than both 3 and 8, x is clearly greater than 8, right? Because it is greater than 3 as well as greater than 8. One thing which combines both of them, okay, is x is greater than 8. Because the moment I say x is greater than 8, automatically it qualifies for x being greater than 3 as well. The second case where the product of two numbers is positive is when each of these numbers is negative, correct? So x minus 3 is less than 0 and x minus 8 is also less than 0, correct? So x is less than 3 or x is less than 8. One thing which qualifies the other is x is less than 3, because if I say x is less than 3, then automatically x will be less than 8. What that means is the solutions for that particular inequality, x minus 3 times x minus 8 is greater than 0, are x is greater than 8 or x is less than 3. Finally, what if it was the other way around, which means x minus 3 times x minus 8 is less than 0? When will the product of two numbers be negative? Less than 0 is negative, right? When one of them is positive, the other one is negative. So the first case is when x minus 3 is greater than 0 and x minus 8 is less than 0. If I combine that, you will get x is greater than 3 and x is less than minus 8, which otherwise means x lies between 3 and 8. Correct? The second case is when x minus 3 is negative and x minus 8 is positive. When will that happen? When x minus 3 is less than 0 and x minus 8 is greater than 0, right? Well, if I combine that, it will be x is less than 3 and x is greater than 8. Now, can you think of any value which is less than 3 but more than 8? Well, no such value possible, right? No such value is possible, which means the solution set for the second inequality, x minus 3 times x minus 8 is less than 0, is x lies between 3 and 8. Well, that's the end of this lesson. We first understood what are inequalities and how are they different than equations. Then we understood some properties of linear inequalities. And finally, we ended up with properties of quadratic inequalities. I hope you understood the concepts learned in this lesson. Thank you.